Hi grade 8, how are you? Okay, we're starting off special cases. As you remember, the special cases, we have two types. We have A2 minus B2, which is A plus B, A minus B, and we have the other side, the trinomials that are made up of three terms. Actually, 9.5 was A is equal to 1, which was one type. The second type was A not equal to 1. Today we're going to be doing the third type, which is the perfect square trinomials. We have two types, perfect squares. We have A plus B to the second power, and we have A minus B to the second power. All right? The difference between trinomials and the binomials, this is made up of two terms, and this is made up of three terms. When we're looking at A2 minus B2, which is a binomial, it is made up of two terms. It's made up of two terms, it's made up of two signs, it gives me two parentheses. So it's two different signs, one a plus, one a minus. If I look at the trinomials, the perfect square trinomials, it's made up of three terms. What is a perfect square? It's a whole number that can be squared. Usually, the whole numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. So 36, what's the radical of it? 6. 49, the radical of it is 7. What's the radical of x to the second power? It's x. Okay? So we have to look for the first term, and we have to look for the third term. Now, the second term that's in the middle, this is used for us to only check. You do not put it not within the parentheses. Okay? It is only for checking on the side of your copybook. Let's take the examples we have here. The first example is y2 minus 16. How many terms are there? 1, 2 terms, and there's a minus sign in the middle. So it's going to give me two signs, two parentheses. What is the radical of y2? It's y. What's the radical of 16? It's 4. So 1 is a minus, 1 is a plus. So I have two parentheses, two different signs, but they are the same terms. Why? Because it's a binomial made up of only two terms. Our second example is 25 m2 minus 36. Again, I have two terms, so I'm going to have two parentheses, one a plus, one a minus. 25 m2, what's the radical of it? It's 5m. Again, it's 5m. What's the radical of 36? It's 6 and 6, and that's my answer. If I look at the third example, it says x2 minus 49y2. Again, how many terms is it? 1, 2 terms. Two parentheses, two different signs. What's the radical of x2? It's x. What's the radical of 49y2? It's 7y, and that's my answer. Right. Another example, 4y2 minus 64. Again, it's two terms. Again, it's two parentheses, two different signs. What's the radical of 4y2? It's 2y. 2y again. The radical of 64 is 8 and 8. So my answer is 2y plus 8, 2y minus 8. The thing that's different is that sometimes we have a GCF before I find my binomial. So the example is 18 minus 18n to the second power. 8, I cannot take a radical of it, and not even 18. So what do? I look for a GCF. GCF here is 2. I put it outside my parentheses. 8 divided by 2 is 4, minus 18 divided by 2 is 9 and 2. Now what do? Again, it's two terms, so I'm going to have two parentheses, one a plus, one a minus. What's the radical of 4? It's 2. The radical of 4 again is 2. The radical of 9 and 2 is 3n and 3n. What do I bring down with me? My GCF. So my final answer with the GCF is a number outside my parenthesis, which is 2, and 2 plus 3n in a parenthesis, 2 minus 3n in another parenthesis. Now we're going to talk about trinomials. I told you that you have to check using your second term. So it's either a plus b to the second power or a minus b to the second power. Let's look at the example. N to the second minus 12n plus 36. The first thing I do is I look at the first and the third term. Can I find the radical of it? Yes. Can I find the radical of 36? Yes. A minus and a plus gives me a minus. Now, how do I check on the side? I take my second term is 2ab. So it's 2 times n times 6. It's equal to 12n. Is it 12n? Yes, it's correct. So this is my answer. N minus 6 to the second power. My second example is 9x2 minus 12x plus 4. Can I change 9x2 into the radical of it? Yes, I can, which is 3x. What's the radical of 4? It's 2. A minus and a plus give me a minus, and this is to the second power. How do I check? I check with the second term, which is 2ab, which is 2 times 3x times 2, which is 2 times 3, 6 times 2 is 12x. Is it correct? Yes, it is. So that's my final answer, 3x minus 2 to the second power. Looking at the third example, 4s2 plus 4st plus t to the second. Again, can I radicalize 4s2? Yes, I can. Can I radicalize t2? Yes, I can. A plus and a plus give me a plus. This is my answer, but how do I make sure? I check. Is it 2ab in the middle? It's 2 times 2s times t, which is 4st. Yes, it's there. So yes, this is my correct answer, 2s plus 2 to the second power. All right, minus 3y2 plus 36y minus 108. First of all, because I have a negative sign, I need to bring it to the outside. 3, there's no radical for it, and 108, there's no radical for it. What do? I look for a GCF. What's my GCF? It's 3. I put it outside my parenthesis, I open my parenthesis. Negative 3y2 divided by negative 3 gives me a y2. Plus 36y divided by a negative 3 is a negative 12y. Negative 108 divided by a negative 3 again is a plus 36. Now, can I find a perfect square here? What's the radical of y2? It's a y. What's the radical of 36? It's a 6. A minus and a plus give me a minus to the second power. Well, how do I check? I go to the side of my copybook, 2ab, which is 2 times y times 6, which is 12y. Is it my second term? Yes, it is correct. This is correct. What do I bring down? I do not forget that I took a GCF of negative 3 to the outside. I have to bring it down with my answer. What's tricky in this lesson is finding your GCF. You have to be careful, okay? And you have to go and repeat the video every time you're solving just to make sure you're on the right track. If I take the second example of GCF, it's 2y to the second power negative 20y plus 50. I cannot find the radical of 50 and I cannot find the radical of 2. What do? I look for a GCF, which is 2 in this case. 2 parenthesis y2 minus 10y plus 25. Now, can I find a radical? Yes. What's the radical of y2? It's a y. What's the radical of 25? It's a 5. A negative and a plus give me a negative to the second power. I don't forget to bring down my 2, which is my GCF. How do I check? I check with 2ab, which is 2 times y times 5, which is 10y. Is it correct? Yes, it's my second term. Yes, that's correct. Okay, be careful just for your GCF. This is what is very tricky in this lesson. Okay, the last example is 3x2 plus 6xy plus 3y2. Again, can I find a radical of 3x2? I can't. Can I find a radical of 3y2? I can't. So my GCF is 3. Put it outside your parenthesis, x2 plus 2xy plus y2. Now, how do I, first of all, I bring down, what's the radical of x2? It's an x. A plus and a plus give me a plus. What's the radical of y2? It's a y to the second power. I don't forget to bring down my 3, which is my GCF. How do I check? I check, is it equal to 2ab? My second term, 2 times x times y, which is 2xy. Is it equal? Yes, it is. So yes, my answer is correct. Right, as a wrap up, I'm just going to remind you of the important stuff you need here. First of all, I have the special case a2 minus b2, and I have the trinomial, which is the last type, which is a perfect square. Usually, this gives me 2 terms, 2 parentheses, 2 signs. My trinomial is made up of a parenthesis, a plus b to the second power, a minus b to the second power. I check using my second term. Don't forget, both can have a GCF, which is very tricky. Look for the GCF before you start working if you do not have a radical to the first and last term. Okay? Yalla, take care, stay safe.